A lot of you, I would venture to say, have heard of companies such as IBM, Google, eBay. Am I right on that? Good. Well, what I do, I am a technician for an electrical company, and we deal with the electrical infrastructure for the data systems for large companies, the utilities, and hospitals even. Well, a while ago, I was sent out to work at IBM's campus in Poughkeepsie, New York. They had an incident, and there were 5 technicians, including myself, that were sent out there. And once we got together and formed a plan of what was going to be done, this person was going to be over here working in the battery storage room. This person was going to be cleaning bus duct. This person was going to be checking switch gear, drying out panels. That was, once we formed our plan of attack, we made a plan and we worked our plan, and in the course of working, we had several conversations, both concerning the equipment we were working on, as well as the equipment that we would like to see installed at this place, and then some extra curricular conversations as well. But one of the common threads was the use of nuclear Navy jargon. There were 4 of us that were former Navy. 3 of those had been what we call Navy nukes. Anybody have an idea what a Navy nuke is? No, no. You think Navy nuke, you think we're going to blow something up, right? Well, that's not what a Navy nuke is. A Navy nuke goes through extensive training to operate the reactor plants and the support systems for the reactor plants on board the aircraft carriers and submarines. And within the program, we develop our own little language. And because we have our own little language, when we're with others that have that similar background, it makes it easier to know exactly what one person is talking about. And what I want to do is I want to introduce you to that language today. I'd like to take you through some of the common things that we say, give you a little bit of background on where they came from, what the experience, where we picked this saying up at, in the pipeline, on a ship, where do we get it from, and also kind of show you how it's used in the industry today. Now, the first thing is, I say don't nuke it. Somebody tells you don't nuke it. What do you think? Don't microwave that? Well, that's kind of a no-brainer, but that's not what Navy nukes mean, or former Navy nukes mean, when we say don't nuke it. When we say don't nuke it, we're talking about don't think too hard. You're overthinking the problem. The answer's right there in front of you. This could be when we're looking at logic for an automatic transfer switch, or simply checking the protection on a system to ensure that it's de-energized before we put our hands in there and go, ah! That's what we mean when we say don't nuke it. We also, hand in hand with that, we also tend to say, well, nuke it out. Wait a second, I just told you not to nuke it. Don't nuke it out? Really? Don't nuke it out. Don't nuke it. Don't nuke it is don't overthink it. But nuke it out means think it out. And in the pipeline, we go through, like I said, a year and a half of extensive schooling before we see our first real live ship or submarine, as the case may be. And when we are going through the school is more than just physics and math and materials and chemistry. The school is, this is how you need to think. This is how you troubleshoot. There are steps. Electrical troubleshooting, for instance, involves, okay, here is the circuit that is a problem. Where is the problem? Where is the failed component? That's where we learn to take deliberate, thought-out steps. Take a reading across half of the circuit. Take the reading across the other half of the circuit. Is it good? Now that we've identified the half of the circuit, we'll split the circuit again. Take a reading again to determine, and we do so on and so forth until we find that one little thing that has caused a malfunction. We'll do that a lot. We will do the same, apply the same logical thinking to troubleshooting circuit breakers. When I test a circuit breaker, a lot of times I'm testing something that has been rebuilt. I'm verifying that it operates electrically. Often I will see a breaker that will charge but does not close. Well, that tells me that I need to evaluate the closing circuit, check contacts within the circuit, check the wiring. But it's much more deliberate to check the circuit than it is to point A to point B to point C to point D to point E, and so on and so forth. Now the next thing that we often say is we refer to somebody as a nub. What's a nub? No, a nub is not the end of your cigar when you're done smoking. A nub is not just some little thing that sticks up off of a plastic jar or plastic anything. A nub is a non-useful body. Where we nukes pick this up at is we pick this up at our first command. When we arrive fresh out of school, I have no qualifications. I'm scared to death. I don't know anybody. What am I going to do? I am not useful until I can stand watch. Until I can support a watch bill, and a real watch bill. A watch bill where I'm actually responsible for happenings within the reactor plant and within the electrical plant. Until then, I am a non-useful body. What do I need to do? Well, they hand me a stack of qual cards and they say, go get qualified. I look at it and I go, ah! No, it's really not all that. I need to, step by step, again, logically progressing, learn the basic theories and systems for each watch. And then I will turn around once I have a good grasp of basic theory, basic systems, even maintenance activities. I turn around and I say, okay, I'm ready to take this qualification exam. The exam is set up, given to me. I turn around and I'm all nervous and I'm thinking, oh my gosh, how am I going to do this? Do I remember this formula? How do I explain this? I can't remember the casualty procedure. What do I do? But I do my best on the exam. And once I've scored a 70 on that exam, I'm then ready for an oral board where somebody with higher qualifications than myself, often an officer, would ask me, what do you do if you see these indications? How do you do this standard operation? It's at that point in time, after I pass that board, that I have now become a useful body. Well, a lot of times now, when we get with the particular shop that I work in, we bring in people with no skills, teach them how to build switchgear, how to repair circuit breakers, how to start from scratch and make what's sitting in your utility substation down the road. We do that, and sometimes we get people with skills. For instance, we had a guy, I'll never forget it as long as I live. This guy had a master's in electrical and electronic engineering, but he couldn't troubleshoot his way out of a paper bag. And the position he was hired for involved startups, very detailed checklist of different functions that are supposed to be checked in switchgear and in drives, different readings that are supposed to be recorded. Could not follow those directions. So they sent him to me, said, can you teach him? Can you teach him how to do all this? I said, I will teach him how how to check breakers. I don't ever see any drives, so I can't teach him that, but I will teach him everything about breakers. I taught Keith, tried to teach Keith how to check a breaker. Well, at that point in time, we had a rush going through. Big end of the year, cram it all in so we can make billing numbers. Said we had a rush going through, had to build, test, and certify 11 ground and test devices for Con Edison. One person would do all the fiber, one person would do the copper, another person would do the wiring. And like anything, when you rush, you tend to mess it up. And not a single one of those 11 were wired completely operational. I brought in a ground and test device for Keith and a ground and test device for myself. I said, check this. He worked his way through checking. He says, okay, what's next? He says, I said, check this. And when he got to where he was ready to test the electrical operation of this unit, it would not work. And I said to him, I said, here you go. Here's a wiring diagram. Here's the schematic diagram. Your problem is obviously in the closed circuit. Find what's wrong. You have a master's in electrical engineering. You should be able to do that. But instead, he couldn't even read the wiring diagram. Could not read it, could not make sense of it. Made him a nub. I had no use for him, and shortly thereafter, the company didn't have any use for him any longer either. Now, we've talked about some standard things before we get into actually operating and actual evolutions. So, when we're getting ready to take and do work, we have to make sure the system's safe. Nobody wants to stick their hand into 15,000 volt gear and get a nice little shock. You might not be going home the same way you came into work that day, if you do, right? So what we'll do is we will tag it out. It's another common Navy term. Well, when you tag something out, in the Navy there's two types of tag outs. There's a caution tag out and a danger tag out. The caution tag out just gives you directions for operating or energizing equipment in a safe manner, such as there's a valve that might be tagged with a caution tag that says only open this valve if the ship is greater than 14 miles from land, for instance. That may be to protect the environment, to protect the ship. It may be to ensure that the ship is in deep enough water so that you don't suck sand into a pump intake. It could be any number of reasons. But the bottom line is that it's only tagged. There's no other, you have to rely on the person that is sent to operate or energize the equipment, reading the directions and going, okay, it says don't operate until greater than 14 miles from land. Well, let me call and see if we're greater than 14 miles from land. Danger tags in the Navy. Danger tags are red and they're tagged, they're checked, they're double checked. The component being tagged, such as a circuit breaker, set of fuses, valve is put into a safe condition for circuit breakers. Oftentimes that is off. For fuses it is removed. For valves it would be closed. That protects somebody from sticking their hand into switchgear and going, you know. It's not, but again, it relies on the person placing the tag to actually, circuit breaker is off, I'm placing it off. It relies on someone not coming by and going, oh, why is that circuit breaker off? Chink, back on. Somebody else down the line gets a shock. It's not good. Well, in the civilian world, we do tag outs. We do a tag out is actually a lockout tag out. There has to be some kind of a locking device to keep that equipment from being operated. Circuit breakers have provisions to be able to be locked open, locked closed. Fuses, you can remove the fuses and then lock the cabinet shut so you can't put the fuses back in. And we're not talking about, oh, just a little, we're just going to lock it with a little luggage lock, No, we use American Standard locks. They come with individual keys, one key per lock. And the only person with that key, and the person that does the tag out, holds the key. No one else can remove that lock, only that person. Much better than relying on somebody not to come through and go, oh, why is that circuit breaker off? And this person over here going, I'm getting shocked now. And another thing, and one of the things that we'll protect downline motor controllers, downline pumps. Why not just turn the pump off at the motor controller? Again, we don't want any chance of that pump being energized at the pecker head when the person doing the maintenance or trying to fix the pump turns around and opens that pecker head and starts taking apart wired connections. What did I say? I said pecker head? Really? No. I'm not calling the guy working on the pump a peckerhead, okay? The peckerhead is a little junction box on the side of the pump where the wires from the motor controller come in and the wires from the motor on the pump, or any motor for that matter, not just a pump. Could be a compressor, could be a dryer, any kind of a motor. That junction box where it is connected to its power supply. That's the peckerhead. Why do we call them peckerheads? Well, on a ship or submarine, there are junction boxes literally everywhere. There's junction boxes for lights, junction boxes for controls, junction boxes for alarms. There are junction boxes everywhere, and often within 2 to 3 feet of each other. So instead of referring to something as the junction box for the ABC pump, well, that to me says the junction box that is between the motor controller and the peckerhead. That's why we call it a peckerhead. Because it doesn't get any more specific than saying that part of the pump is what we're working on. Finally, one of the other things that we work on is we work on what's called an ABT, an automatic bus transfer system. In civilian terms, that's an ATS switch, an automatic transfer switch. What they do is they ensure continuity of power to critical loads such as hospital lighting panels. You don't want the lights off in your OR, do you? I didn't think so. Well, the automatic bus transfer, it starts on one source, and if that source loses power, it will black out for a period of time until it moves to the other source. Well, an ATS switch does the same thing, and the big difference between the two is that an automatic bus transfer, the technology is so old, it's done through resistors and relays and actual moving contacts. Whereas with ATS switches, the automatic transfer is done, you have a solid state electronic relay that says, okay, I just lost power here. It sends a signal to another relay, says, do you have power over there? This relay says, I've got power over here. This relay sends a signal to this relay. It says, open open the circuit breaker for the dead side.